On the bench today is a Marantz 1250, built in 78, 79, the year that I graduated. There was a lot of party going on back then, and this is a 125 watts per channel. Weighs 40 pounds, ridiculously heavy. The customer brought it from another guy. When he went home to plug it in, he's saying there was a lot of static in the speakers, but he does say that left and right are both working. I assume all these pods and switches needs to be cleaned. There is, he said, an issue. There was some noise coming out of the power on and off switch. I'm really not sure what he meant by that, but anyway, this is his second Marantz that he brought on here on this bench. So I told him that I would take a look at it, see if we can find some interesting stuff with this Marantz. Alright, here we go. I'm gonna power this on and see what happens. Take a look at my light bulbs. Lit up. It dimmed back down. But it's drawing quite a bit of power. I'm at 96 volts here, so we're talking about 30. It's drawing about 30 volts. It's a bit high for just on idling. So what I'm going to do is I want to check some DC voltages on here. See if it's safe to hook up my speaker to see to this right away. Okay, so we're drawing. I want to make sure that I have the right speaker terminal. Got this on auxiliary, main. Okay, there's the main speakers. Drawing quite a bit of DC voltages on here. Where's my volume button? This is the volume button. Okay, I'll put this on neutral. Okay, auxiliary. Okay, so I'm drawing from the right channel, 62 millivolts. Try the left channel. The left channel. Are you kidding me? A 0.2. That's quite high. So we have an issue with the DC offset. 0.06 for the right. 0.2. Yeah, there's on the left channel. Let's try this one. 0.02, same thing. 0.06, okay, same thing. Okay. So the left channel is drawing quite a bit of voltage there. But anyways, the best thing that I can do right now is I'm going to open this up and we are going to check some voltage. I am going to get the schematic for this Marantz 1250. Okay, I'm going to shut this off and I'm going to take the cover off and we're going to do it right now. Wow. This is compact. Here's my filter capacitors here. I know you only see one capacitor, but underneath this canister there's actually two capacitors of 14,000 microfarad each underneath here, and I'll show you that. It's written right on the side as well, ×2. And I should have 60 plus volt. Okay, you guys can see this. +63. This is my +63. My -63. The only one that I didn't check was this one way down in the bottom. The transistor is way too close to the chassis. I don't want to create a short there and get a zap or ruin my equipment. But I mean, if all these three are 63, I'm pretty confident that that one there is 63 as well. And the same thing on both sides. Everything is working. Seems to be working fine. I'm confident that they're all four of them are 60. This one is 63, 63, 63. I'm pretty sure this one is 63 as well. I'm not gonna, like I said, I'm not gonna poke in that because it's just too close to the chassis. I will get a zap if I do that. But anyways, right now, kind of looks like I'm getting my voltage, which is okay. So I'll shut this off and I am going to put in my speakers. Okay. It didn't blow the fuse. Okay. Let's check if I have any voltage on it. No voltage. Okay, I'm on the Marantz today, and I've come to a conclusion where this thing totally stopped working. Power on and off switch, it was plugged in, power on and off switch, nothing was happening. I thought maybe there might have been some fuses. All the fuses checked out, and but I had no power, but I had some going to the on and off switch. So I come to the conclusion that it might have been the on and off switch. So I cleaned it out with some contact cleaner, and nothing was working. So what I've done was I bypassed the switch, and when I plugged it in, I had power. So I knew I have a defect power on and off switch. Don't know what I'm going to do to replace this. Have no idea. This Marantz is, I don't know, it's probably 30-40 years old. If you'd have to order one of those, it would cost you an arm and a leg. So knowing that there's something wrong with this switch, I'm going to take it apart and see, maybe I can repair it. I'm not sure. And knowing that I've done the bypass and it turned on, I know I have a defect switch. I need to either replace it, try to repair it. I have two choices. I'm going to try to repair it. Okay? So red, brown, and orange. Got that on tape. I'm going to take a picture of this. It's always good to take pictures of it before you start working on it, because then you can always come back to the picture and make sure that all the wires are connected. So what I'm doing is I'm going to cut these off. Seems to be working okay. Here. That I'm thinking. There we go. It looks pretty dark inside, Just wanted to show you guys how dark it was on the inside. So I believe that the contacts in here are burnt. I'm not sure if I can repair this, but maybe I can just clean them out. So we'll see. I'm not sure if that's soot. Yeah, this thing is done. This is cooked. I don't know if you guys can see this, but it's just too far gone. I don't think I can repair it. So we'll just have to find another solution. But anyways, you compare to the one on the bottom, check the one on top, and I've replaced it with the very same, almost same switch. Okay, now that I've replaced the power switch, I've got it plugged on my dim bulb, and I'll see if this is going to power on. Well, my lights come on. Yeah. Power's on, and the relay kicked in. So it's a good sign. The switch is working properly. Okay, I'm going to shut it off. Now what I want to do is, since I've had an issue with the switch, I really want to check my power supply board, which is this one right here. And I've got a relay underneath here as well, so I'll be checking that. So what I need to do is I'm going to take this plate off, top plate off, and we're going to do that right now. Okay, so I'll take this board off. There's 4 screws, 2 on each side, and then I'll remove this from the plate, and I'll check the capacitors on here, and then after we've checked the capacitors, we'll check our voltage. According to this, and there is some adjustment on this power supplied circuitry, and if I check pin J810 and J816, which is the 2 far ones, I should be having minus and plus 55 DC volts. Okay, so I'll check that. And if I'm not getting that, there's potentiometers or trimmer pods that I have here that I can adjust. And I'm assuming that might be a reason why we had an issue, and I did blow 2 fuses. They were the main fuses from the back here. So that's directly from the power supply. Okay, if I have an issue with power supply, this fuse is going to let go. Okay, so I assume that I might have an issue here, and I'm going to check this out. I am checking capacitors on this power supply, because I do seem to be blowing some fuse for no reason at all. And it's the main fuse, so I will need to check everything about the power supply, see if I'm getting good voltage. And right now what I'm doing is I'm testing capacitors in this orange cap that is right here is not reading anything. That would be the only one. There's another one as well, this one here. So got these 2, one cap here reading 5 ohm. This one here is reading good, but this orange one is reading high in ESR. So I will change those 2 orange caps right here. I don't know their values yet. It's hard to see, but I'll take them out of circuit and we'll go from there. Excuse me, I do have COVID, so And this is the one here. So those two caps are coming out. And there it is. It's a 4.7 microfarad at 30 volts. Sure enough, it's a dead cap. You guys can see this eye. Dead cap. It's open. An open cap. Look, it's not even reading ESR. It's this cap is open. Okay. So this is a 4.7 microfarad at 30 volts. Oh, sorry, this is a 50 volt. So, and here's the other one that I'm going to replace as well. This one is reading okay, but I'm not going to take any chances. Usually the orange caps, in my experience anyway, they've always they were always high in ESR. So it's a good idea to check them, especially the orange one, or to replace them. Okay, so here's the other one, exact the same, 4.7 at 50. This one was still reading, but high though, 6.19 microfarad. We'll give it another go with this one. So this one was actually still okay, but I'm pretty sure it's high ESR. Yeah. The value, it was still reading the cap, but the value is way off. ESR is 4.2. And voltage loss was at 3%, so good thing to replace this. Just always make sure that you have the polarization correct. I'm going to dismantle this. Now these caps, I will check all of these caps. Oh, this has been worked on before. We had a lot of heat damage here, and they've tried to fix it. Oh, look at this mess, eh? I don't know, it could be something with the relay too, I don't know. Doesn't look like they've replaced the relay. So I've got 1, 2, 3 capacitors that I'm going to check on this. They're really not that high in voltage. Don't suspect that they're bad. One's good. This one is good. Yeah, this one's not so good. Yeah, it's good. It's less than a ohm. Okay, so this has been checked, this has been checked, and we've changed 2 capacitors that are completely open. Okay, this is the power supply adjustment. I have, I'm supposed to get on J810, J816, plus and minus 55 DC volts. Okay? So, on the pin 810, I have 59 volts. You see that? And I should only have 55 volts. Now, if you noticed, I put a sleeve, like a heat shrink, on my screwdriver because I gotta go in between pins here and I don't want to create a short. So it takes a long screwdriver because the pod trimmer is way down now. So I'm gonna try to bring this down to 55 DC volts, and I have it on DC. So 55, 55, come on in. There we go. That's 55.11. That's on pin 810. I will try pin 816, which is this one right here, and I have 50 volts on this one. So this one, try to bring this up to 55. There's 55. Okay. Try the other pin, see if it's readjusted itself. No, 55. So I'm good with that. Okay, so the power supply adjustment has been adjusted to 55. I'm pretty happy with that. I'm ready to put that cap back on. Power this off. And I've got no power here. Unplug this from the wall. And here we go. I do have a lot of noise on this pot. The volume potentiometer is really dirty, and it's really hard to get. But the rest of it seems to be okay. So in order to get to this potentiometer, I'm going to need to take this circuit board off. So I'll need to unscrew these two screws, take this off, and that'll expose the potentiometer. Okay, so we're going to shut this off, making sure that everything is okay, and I'll get to work. Before I can take the filter amp board out of there, that will give me access to the volume potentiometer underneath here. I'm going to need to take the amp board out of there, which I was planning on doing anyway. There's a couple of caps on this right side, and I think there's 3 caps on this that I need to check. So first things first, I'll have to take this out, which I was planning on doing anyway, and I'll show you how I'm going to do this. And then that'll give me access, more room to take this one out and expose the volume pot that's underneath here. And while I have this out, I will be checking some capacitors on this. So my next step, I'm going to remove the right side amplifier board. We'll check the capacitors on this. I know this seems like a big job, but I'll show you that it's really not. This Marantz was well made. So you take this up. Okay. There, this comes right out. Totally access to this. So what I want to do is I want to check. There's a few capacitors. There's 1, 2, and 3. And you know what I feel about these orange ones. They're always, if you're going to change a capacitor, it's the orange one. So I've removed this. Now I should be able to remove this. Now there's my volume potentiometer fully exposed, and I'm going to spray in here. because he was really scratchy. Marantz got a really good reputation. Very seldom you'd have to touch their soldering. It's really good, and even their capacitors are. I've changed two on the power supply board, and of course they were orange. These damn orange ones. So here's one. Here's a great big cap here. Man, what the hell? Yeah, it's good. Good cap. And the other one is back here. This one right here. This one is showing. This is not good. I'm showing 10 ohms on this one. Okay. I'll show it to you guys. 10 ohms. And this is the cap right there. Right here. You guys see my meter? Okay. Sorry. This is showing 10 ohms. This needs to be replaced. Okay, this capacitor is 100 microfarad at 35. Let's see what it measures out of circuit. I mean, I'm saying a little bad on this. Honest to God, yeah, I've got I got about 9 ohm of resistance on this. I need to change the battery on my capacitor meter, but I'm going to use this. This is pretty precise too. Here we go. 100 microfarad. It's showing 12 ohms. 12 ohms, 6.6 voltage lost. And this is supposed to be 100 microfarad, and it's running at 70, and I'm reading it at 77 microfarad. Yeah, this thing was done. We're going to replace this with a brand new one. 100 microfarad at 35 volt. Now, what I'm going to do is I'm going to check 1, 2, and 3 capacitors on this board. Alright, so these 4 screws there are 6. Okay. Like that. Perfect. this cap right here. That's saying it's good. The second one is the orange one. Don't be surprised if it's not. It's good. And this little one back here. I think it's this right here. Yeah, it's good. Back in place. Just make sure you don't pinch any wires when you do this, okay? Just it's really important that you guys do this. I'm gonna be setting the DC offset and the bias. The bias is set at 10 millivolts and the DC offset, well, you know what that is. This has to be 0 DC volt. Okay, for the bias adjustment, we have this the idle adjustment is between J715 and 716. The potentiometer is R724, I guess. And we are looking for 10 millivolts. Okay, so we have 5 on the right. Let's get this up to 10 millivolts. There's 10. 10.3. 10.2, look at that. 10.2 for the right. Let's go check the left. Left, I gotta wiggle this around a little bit, but I should be able to do it. There's 1. And there's 2. It's at 9.1. Check that out. So we'll bring this as close as 10 as we can. .1. So the left channel 10.1, this one is 10.2, I think. So the bias is set. Now I want to see if I have DC voltage on this. I'm going to do that right next. DC voltage coming up. Okay. Okay, so this is what I'm getting for DC voltage. It's quite high actually. 0.1. So I do have some voltage on there, but we are going to correct this with this potentiometer. Let's bring this down to almost 0. I'll put this on millivolts so we can see. Okay. That's fantastic. 1.5 millivolts. You're talking 0.001 and 2. That's perfect That's for the right channel. All right, let's do the left channel. The left channel is at 0.2. Yeah, that's way too high. So we'll kick this down. As close to 0 as we can. I'll put this on millivolts, and here we go. .2 millivolts. Look at here, guys. This is, don't come any better than this. This is 0 voltage, DC voltage, on my speaker terminals. So all 3 of these have been set according to the service manual for this Marantz. I'm really happy with this, and the only thing left to do now is I'm going to put this through scope, and we're going to test this out. I've got a single generator going in through my auxiliary, going through my scope and my speakers. I will mute my speakers. Okay, so I'm set to 10 volts per division. No, I wasn't, so I'm going to do it right now. Okay, we're good to go. So I've got this hooked up. I'm going to put this on an 8-ohm load. Zero distortion that this thing has, and I'm pushing 30.4. There you have it. The Marantz 1250 has finally been restored to what I wanted it to be. It gave me a lot of challenge. It caught fire, and it shouldn't have caught fire because I was under a safe environment where it shouldn't have happened. I do believe there was a faulty switch that just happened, that it was on my bench when it happened. I'll show you that on a video as well. I'm not hiding anything. The power supply board was not, the voltage was not set properly, which I do believe caused a lot of issues along the way. I was able to change some capacitors that were open on the power supply as well. I was blowing a couple of fuses, and all this is all twined together. So anyways, I was able to find these issues, repair them, and you'll see them on the video. The bias was set to 10 millivolts. The DC off, I had some DC offset prior to when I started all this. This whole system, this whole amplifier was not set, and it came to the right spot on my bench. I repaired it, and I'm pretty happy with it. I'm going to call the customer tonight, and I'm pretty sure within an hour he's going to be here to pick this up. It's Friday night. Yeah, he'll be here. All in all, challenging but fun project. If you like my video, thumbs up. Give me some comments. I really would appreciate comments, especially on this. And subscribe to my channel. I would really appreciate it.